Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome back to my YouTube channel. My name is Aliyah Rumini Larasati, with my ID number is 4192111004. In this video, I will continue the discussion from the previous video. Today, I will tell you what I know in the chapter 13, namely about development of modern mathematics from transitional century to 21st century. The scientific revolution period. The first one in 17th century. In the 17th century, within an unprecedented increase in mathematical and scientific ideas throughout Europe, Galileo and Galilei was able to observe Jupiter's moon with his homemade telescope based on toys imported from Holland. Tycho Brahe managed to collect a large amount of mathematical data describing the position of the planet in space. Johannes Kepler studied the motion of the planet seriously and put forward Kepler's laws. He also made a mathematical formula of laws of planetary motion. René Descartes developed analytic geometry by placing the orbit of the planet into a graph of Cartesian coordinates. Isaac Newton is perhaps best known for his contribution to physics. However, his service in mathematics shouldn't be underestimated. His most famous work is Philosophiae Naturalis Principia Mathematicae, which has first published on July in 1687. In formulating his physical theories, Newton developed a method that we know today as a calculus. Newton's calculus at that time used a different notation from modern calculus notation. Because of this, Newton is considered one of the founders of calculus. Another discoverer of calculus was Wilhelm von Leibniz. He is considered one of the most important mathematicians in history. Separately from Newton, Leibniz developed differential and integral calculus. In his calculus, Leibniz introduced a notation that is still widely used today, like d for derivative and for integral. Leibniz also contributed to algebra and topology. He was the first to understand that the coefficient of a system of linear equations could be arranged in rows. We now call them matrices to find solution to the system of equations. This method was later called Gaussian elimination. Leibniz is also known as a polymath and philosopher. Apart from astronomy and physics, the application of mathematics developed in new directions. Blaise Pascal and Pierre de Fermat teamed up to investigate probability theory and combinatoric rules in their discussion of gambling. In 18th century, the most influential mathematician of the 18th century was arguably Leonhard Euler. One of his contributions was the discovery of a study of graph theory with the seven bridge of Königsberg for standardizing many modern mathematical terms and notation. For example, it represents the square root of -1 with the symbol e. He also popularized the symbol p to express the ratio between the circumference of a circle and its diameter. He made many contributions in topology, graph theory, calculus, combinatoric, and complex analysis. Another important mathematician of 18th century was Joseph Louis Lagrange, who did pioneering work in number theory, algebra, differential calculus, and the calculus of variation. There was also Laplace, who had done important work on the foundation of classical machine and statistics. Modern area in 19th century. During the 19th century, mathematics became increasingly abstract. Carl Friedrich Gauss, known as a prince of mathematics, made revolution work on complex variable function and the convergence of series. He was also the first to give satisfactory proofs of the fundamental theorem of algebra and quadratic law. In this century, also developed two new geometric shapes beside Euclidean geometry. The Russian mathematician Nikolai Ivanovich Lobachevsky and his rival Janos Bolyai, the Hungarian mathematician, spreadly defined and studied hyperbolic geometry, while one other form, namely elliptical geometry, was developed by the German mathematician Bernhard Riemann in the late 19th century. He also developed Riemannian geometry, which unifies and broadly generalizes the three types of geometry, and also defined the concept of the manifold, which generalizes the notion of curves and surface. In 19th century saw the beginnings of math abstract algebra. Hermann Grassmann in Germany provided the first version of vector shape. William Roman Hamilton in Ireland developed the non-communicative algebra. The British mathematician George Boole devised an algebra that soon unfolded into Boolean algebra, which contained only the number 0 and 1. Boolean algebra became the starting point of mathematical logic and had an important role in computer science. Augustin Louis Cauchy, Bernhard Riemann, and Carl Weierstrass reformulate calculus in more guided way. In this century too, for the first time, the boundaries of mathematics were explored. Niels Henrik Abel in Norway and Farid Giolis in France provide that there is no general algebraic method for solving polynomial equation with more than 4 digits. On the other hand, the three-dimensional limitation in geometry was achieved in the 19th century by considering the parameter space and hypercomplex number. Abel and Galois' investigation into the solution of previous polynomial equation laid the foundation for the development of group theory as well as fields related to abstract algebra. In the late 19th century, George Cantor built the first foundation of the set theory, which allow us to understand previously the idea of infinity, and it has become a common language in almost all branches of mathematics. Cantor's set theory and mathematical logic, developed by Peano, L.E.Z. Brouwer, David Hilbert, Bertrand Russell, and A.N. Whitehead, are considered the basic foundation of mathematics. In the 19th century, several mathematical communities were established. These include the London Mathematical Society in 1865 and Société Mathématicienne France in 1872. The Edinburgh Mathematical Society in 1883 and Corcolo Mathematico in 1884 and the American Mathematical in 1883. And then in the 20th century, saw how mathematics became a mainstream profession. Every year, thousands of doctorate degrees in mathematics are awarded, and there are many jobs available in education and industry. In 1900, David Hilbert is sent to the International Congress of Mathematics, present a list of 23 unsolved problems in mathematics. This problem, which cover many eras of mathematics, become the main focus of much of the mathematics of the 20th century. Currently, 10 have been solved, 7 have been partially solved, and 2 are still open, and 4 issues have yet to be declared solved or not. Several conjectures that stand out in history have been provided in 1976. Wolfgang Haken and Kenneth Appel used computer to prove the four-color theorem. Andre Wills proved a Fatmas-Latz theorem in 1993. In 1998, Thomas Callister Hales proved a Kepler conjecture. Mathematical collaboration of unprecedented size and scope. An example is the classification of finite simple group, whose proof between 1955 and 1983 required 500 journal articles by about 100 authors, and field tens of thousands of pages. Differential geometry emerged when Einstein used in the general relativity. Entirely new fields of mathematics such as mathematical logic, topology, and game theory have changed the types of questions that can be answered by mathematical methods. All types of structure are abstract by axiom and given names like metric space, topological space, and etc. The concept of abstract structure leads to category theory. Grothendieck and Serre construct algebraic geometry using shape theory. Great progress was made in the qualitative study of dynamical systems, started by Philosophia. Measure theory was developed in the late 19th and early 20th century. Its application include Lebesgue integer, Kolmogorov axiomization of probability theory, and ergodic theory. Knot theory is developing rapidly. Quantum mechanics broke the development of function analysis. Other new fields include Lorentz quartz distribution theory, fixed point theory, singularity theory, and Ransom's catastrophe theory, model theory, and Mandelbrot fractal. The continuous development and improvement of computers allow industry to deal with larger and larger amounts of data to facilitate mass production, distribution, and communication. With this development, new fields of mathematics have also developed, including Alan Turing's computability theory, complexing theory, data analysis, and optimization. In the previous century, most mathematics focused on calculus and continuous function, but the development of computing and communication network made the concept of discrete and combinatoric exchange even more important, including graph theory. The ability and speed of data processing on the computer enables and handling of mathematical problems that take too much time to do with a pencil and paper, leading fields such as numerical analysis and symbolic computing. Some of the most important methods and algorithms of the 20th century include the simplex algorithm and fast Fourier transform, error-correcting codes, the Kalman filter from control theory, and the RSE algorithm of public key tripotry. One of the most interesting mathematics in 20th century was Srinivasa Iyengar Ramanujan, an Indian self-taught who had guessed that proved more than 3,000 theorems, including properties of very high compositing numbers, partition function, and their asymptotic, as well as a mock theta function. He also made major investigations into gamma function, modular forms, divergent series, hypergeometric series, and prime number theory. Then, in the mid-20th century, in the United States, there was a mathematics teaching approach led by Baberman in 1851, namely the University of Illinois Combined and School Mathematics, which emphasized understanding and discovery. Because this project is the forerunner of modern mathematics, Baberman, as the leader of the project, is called the father of modern mathematics. One of them created a modern mathematics movement, which is a continuity of the UCSM project, namely the SMSG project aided by R.A. Bigley in 1958, the result of which were able to make a big difference not only in America, but also for the teaching of mathematics around the world. And in 21st century, in 2000, the Clay Mathematical Institute announced 7 Millennium Prize problems. And in 2003, the Poincare conjecture was solved by Grigory Preleman, who refused to accept the award because of his critical attitude towards the establishment of mathematics. Many mathematics journals now have an online version, such as the print version, and many journals are only published in online. There are many observed trends in mathematics, the most notable of which are that the subject is getting bigger, computers are getting more important, and powerful. The application of mathematics to beyond information is growing rapidly, and the volume of data generated by science and industry, facilitated by computer, is explosively growing. Okay, I think that's all I can explain in the chapter 13, namely about development of modern mathematics from transitional century to 21st century. If I have something mistake, please forgive me. And thank you for your attention. See you in the next video. Goodbye. Wassalamualaikum warahmatullahi wabarakatuh.